going to build a simple application with CEM. Deployed a form engine base objects like shown in the configuration video, so I already deployed that, and I have imported objects doing simulation of energy. The structure of this simulation is relatively simple. I have for each to simulate, I have a simulation object, and I have a that represents actually the physical meter. And the idea of this approach is that the simulation is ongoing, representing the energy use. It simulates both the consumption and the demand. And the physical meter represents really the IOs reading from the simulation. It allows me, in fact, to simulate a meter going online, offline, whether it is deployed or undeployed, with affecting the counters of the simulation. Simulation still continues to count upward, and the physical meter, I can turn it on and off, and that way simulate online, offline again. So I don't have to worry about that anymore. So let's create a simple meter object to do it at the instance level. Normally we would go through derive template and create a hierarchy following good practices for application server. For simplicity, I'm going to create an instance directly. I'm going to just call it CEM power main. Here we go. And to drop it under the meters area, configure it. So general things, first you need to specify what type of electricity, gas, or meter, what type of energy. Then what is the model number of the energy meter we're looking for. We have previously configured that in the previous video under configuration. Then we're meter behavior, which is either physical, virtual, or delta. In this case, it's physical meter. We're having really a meter on the main. The meter can be online or offline. So the meters that are connected and providing an I/O are online meters. Offline are those where you have to take manual readings and then upload the data through a file or manually enter it using the data addition tool. The goal is how often do you want to record your energy data. You typically combine that with the utility company recording intervals. For example, every 15 minutes or every 30 minutes. For the purpose of this demo, I'm going to use an interval of 1 minute so that we see data appear a little more often in the database. Offset is from the top of the hour, start time of the recording interval. For example, if you have a recording interval of 3 minutes and you want to record from minutes past the hour and 37 minutes past the hour, you set your interval offset at 7 minutes. Tolerance limit is really a amount of time that we allow when we upload data from a file. Well, the timestamp of the data may not be exactly aligned with the recording intervals in CEM, so that tolerance limit allows for a certain gap and tolerance for those recording intervals. We have a description, and the last factors are for the offline behavior. So typically we do want to enable the auto offline. We actually detect when the meter goes offline, and CEM continue to create recording interval for that meter, which can be filled afterwards either manually through file or even through interpolation, interpolation. So when the user goes back online after being offline for a certain time, C automatically interpolate the consumption data plus all the intervals that were offline. So is the duration of the general settings. If we go to consumption, this is we specify the I/O in which that has the consumption data. So this is a counter that has that value. So in my case, I'm creating the main object. So I will use the physical meter. This is not using the simulation, but really the physical meter that I can take online or offline by deploying or undeploying. And attributes, meter value, which is the consumption, and the demand. So I'll use meter value for the consumption. It's a double. Units of measure are kilowatt hour with kilowatt hours. Roll in my simulation, I've set it to 1,000 so that we do see rollovers regularly. Value band is really the dead band due to skip the creative interval if the energy consumption is too small. 0 or to a small value like is in here, really depending on how often do you want to have new integrated in the database. You can detect rate of change. So if the meter has a big spike, it may be bad data, and you check that with CEM. So it's one type of validation of the data. So you see that the you can configure rate of change, a maximum rate of change, either per second or absolute. I prefer per second because it's clearer. Otherwise it's absolute. Each time we read the value, time the engine reads the value, you compare the previous value. I'll use maximum delta per second, and I'm going to set it to a large number so that I don't actually to detect rate of change at this time. So consumption. The new feature in CEM 2014 R2, you can enable this demand attribute and compute demand in one of two ways. Either it will compute the average demand based on the consumption. So basically taking the consumption by time, and that will tell you how much, what average demand during that interval, basically. Specify the unit conversion factor depending on how you want to deal with that with base unit of demand. And now we're dealing with kilowatt hours and kilowatt for the base unit for demand, so I'll set it to 1. For demand is the detecting actually the maximum during the interval based on an I/O. So that's what I will do. I'm simulating demand in my simulation there. Let me pick the demand attribute. Unit of measure is kilowatt. And that's it. Now we're going to record demand with each interval along with consumption. Things are additional attributes that you can use to provide information on your meters. Unit rate schedule, especially on the main, this is where you define it. So I'll define a rate schedule. The rate is very simple. You specify a time. So midnight, what is the cost? The cost is, let's say, 0.1 cent per kilowatt hour, the base unit, and I can do that we'll put it at 6 a.m. We're going to and go higher. Set this to 0. I could have typed it. It would have been faster. So let's put this at 0.15 and call it morning and say at 10, 0, and we're going back to 0.1 and enter. So this is the default again. So you get additional rates like this. Enter rates for special periods also, and you can enter. You need to enter the annual period. So let's create a period. We're going to say here from January 1st on the days rate 01 that we've just created applies. So I'm keeping it simple. I'll create another session to explain how the rate schedule actually works in more detail. So we have schedule defined. We're good. And tickets were already there. You can define targets. You can define additional attributes and report values. But this is good. We have configured our CEM meter. We can actually deploy it. And we, after that, create additional meters. And that's what I'm going to do as part of next steps. Create for each of the areas that I have done with my simulation. So what I'll do is pause the recording, create meters, and just come back afterwards just for keeping this video relatively short. So I created additional meters in line with the little project I want to do. Once I realize I forgot and I get caught times, I need to undeploy my main object because it's not licensed. So when the object is not licensed, you get no recording in the database. So what we do now is configure object licensing now that we have created all our objects. So let's click on that. We found objects that are not licensed, license all features. They are licensed, that's it. So now we can deploy and it will record data. So this simulation, I have the power main. I have for line A, line B, which are physical, configured the same way as the main with the rate, because the rate is defined in the main and will cascade down to the child meters. I have created also, there was a physical meter or physical meter here for utilities. I created a meter for that. Special meters are power office, and power office is basically going to be a delta meter. It's going to be the residual energy from the main and the other meters below, and we'll see that in the hierarchy. So the meter is configured the same way. I've created an additional type model number and set the recording intervals. In the case of consumption, we put nothing. There's no I/O for this. It's computed from other meters. I've set the units of measures and the maximum rate of change again. And is not configured in this case. So that's good. Let's save that. And this production line, which is a virtual meter, it's the sum of the child meters. So what I'm going to do now is configure the hierarchy. Step before deploy. Let's go to the, we're going to build it. So start with the main, then the main we're going to have the production line and the utilities, whoops, utilities and the office. And the production line is actually the sum of power line A and B. So this is hierarchy, very, very simple. Two production line, a virtual meter, computing the sum of those child two lines. If I collapse, we have the main meter, which is a physical. This one, which is the sum of the two physical below, power utilities, and a delta. So the difference between the main and the two other meters will actually be assigned to the office energy. That's it. Let's apply that, and we're done. So we now deploy those objects and start recording data. We have now a small application.